Question that we are going to solve today is number of islands. This is problem 200 in LeetCode. The difficulty is medium, and the question goes, given an m times n 2D grid map of 1's land and 0's water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. If you see example 1, input looks like this. This is a 2D grid. So if I quickly draw this in the note. So the grid looks like this. And the output here is 1 because there are only 1 adjacent lands, which looks like this. This is one big land. If the last element was 1, then the output would be 2 because we have one big land and small separate land. The example 2 looks like this. The output is 3 because we have one land here, another one, and the last one. And all 3 of them are not close. They're not connected with each other, right? So how we are going to solve this? We are going to use an algorithm called DFS. This stands for depth first search. So to show this by hand, let me just make a simple grid. It will be 3 by 3. It will look like this. Maybe this. It will maybe look like this. And then we are going to loop from the first element to the last element by row. So if we have a pointer here, we'll use a for loop. If we look at the first one, the first rule is we are only going to look for the ones, which is land, right? So if 1, then we're immediately going to change this to 0 to indicate that we have visited this element. So first thing, we are going to change 1 to 0. And then if 0, we are just going to ignore. Or we are just going to continue. So if this was 0, we are not going to do anything. We're just going to the next element. But since the first element is 1, what we're going to do is we are going to look at upper element, and then right element, below or down element, and then left element. So if this is 1, we are going to look at the upper element, but we don't have an upper element, right? Because this is the first row. So we are just going to proceed and then look at the right one. But since this is not 1, this is 0. So whenever we look at the upper or right element, we are going to recursively go back to the loop and then do the same thing. So we're looking at the right one. But since this is not 1, this is 0, so we are going to just continue. Do that thing and then come back. And then we look at the down one. Look at this one, and this is 1, right? So we are going to do the same thing recursively. So we will have a new pointer here, and then do the same thing from the first line. If 1, then change it to 0. Oh, we forgot to change this to 0. Here we have to change this to 0. And from here, we have to change this to 0, right? We change this to 0. We look at the upper one. Look at the upper one. But since this is already 0, right? Because we changed this from 1 to 0 to indicate that we have visited this node. So if 0, just continue. We do nothing and then come back and look at the right one. And this is 0. We continue. We come back. And we look at the down one. This is 0. We come back. We look at the left one. There's nothing, right? So we come back. And finally, we're done with this one. After we're done with this node, we come back to our parent node where we came from, and then proceed from here. So here we ended up doing down one, right? We went here and then came back. So we look at the left one, but there's nothing. So we come back and we are done with this node. So if 1, and then if we are done with the toppest one, then add to our result. So our result indicates, our result is like to count how many lengths we have, right? So we add 1 here. So before, these two were 1, right? But through our depth first search, through our DFS, we found that there's a one big connected length, right? And we have changed these to 0 because we know that we have visited these two elements. So we're done with the first element. We move next. For this one, this is 0, so we just continue. We do nothing. We don't do any recursive loop. We just continue. This is 0 again. We continue, 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 and this is 1, right? So now we're going to do the same thing. If 1, then 0. We change this to 0, and then look at the upper one. This is 0, so we come back. Look at the right one. This is 1, right? So we have to do recursive. From here, we start again. If 1, then 0, right? So change this to 0. Look at the upper one. This is 0 already. Look at the right one. There's nothing. Look at that one. There's nothing. Look at the left one. But since we already changed this to 0, we don't have to do recursive again from here, right? So we come back, and we're done with this, right? When we're done with this, we come back to our parent node. And here we ended up looking at the right one, right? So we look at the down below one, there's nothing. Look at the left one, it's already 0. So we come back, and we are done with the toppest one, right? This is the toppest node. So add to our result. We add 1, so it's 2 now. We look at the next element. Here, this is already 0, right? If we didn't change this from 1 to 0, we don't know that we have visited this node, so we will do the same thing, and we will end up adding 1 here, right? Which will be different from the answer, right? But we know that we changed this to 0, and we know we have visited this node because we included this node with this whole land, right? So we don't have to do anything, we just proceed, and that's end of the loop, right? So we had a land like this, and the answer should be 1 and 2, and we got our result, right? So to code this, first of all, we'll need to initialize our results, right? Int result is 0. And then what did we do? How did we do the for loop? We have to look at each element in 2D array, right? To do that, we need two for loops. Int I equals 0, I equals grid length, I plus plus, and then another for loop in j equals 0, j grid I length, j plus plus. And then here, we have to, after we do something, right, we have to decide either to add 1 to our result, or case like this, we have to add 0, right? We did nothing to our result, right? So here we have to do something, and then like do something here, either add 1 or add 0, right? To do this, we are going to use a helper function. Helper function is going to look like public DFS char. We are going to pass the grid, the exact same grid from here, and then int I, which is our row, int j, which is our column, right? And then we will need to return an integer to add here, either add 1 or 0, right? In that case, we are going to use DFS grid ij, right? So grid, we are passing the same grid. I, this is our row. J, this is our column. So in our helper function, if you look at the first element, or if this was 0, right? This was 0. We're looking at this element, right? If 0, we do nothing, right? We just proceed. So what we're going to do is if grid ij is 0, we return 0, right? So if grid ij is 0, we return 0. So that when we meet this 0, we'll return 0, and the result will not change. And then we move to our next element, right? So we move to our next element, 0 again, return 0, 0. But at first here, oh, never mind, 0, 0, and then we come here, right? So this is our 1. Now we need to do something. So the first thing we did whenever we met 1, we changed this to 0, right? Change this 1 to 0, right? So to do that, we have to do grid I, j is 0. In that case, this will change this to 0, and we have to look at the upper one, right? We look at the upper one. So to do that, we recursively use this function again and grid I. So to look at the upper one, it's going to be I minus 1, right? And then j, right? Yep. Look at the upper one. And this will go recursively again. So this will go here again. But if grid I is 0, return 0. So it will just return 0, right? Just return 0. But here, even if this is returning integer 0, we didn't put anything in front, like we didn't put anything like int x is 0. It's okay to not put anything. And then the output would just be void. And then we look at the right one, dfs grid I plus 1, no, I and then j plus 1. And then grid I plus 1 j, which is going to be down. And look at the left one, grid I j minus 1. But here we will meet an error because from here we look at up, right, down, and we look at the left one, the I here, or the j. This is our I, this is our j. But this is our j when it's 0, right? But if you look at this one, the j is going to be minus 1, and it will return index down to bound error, right? So whenever we go through the edge cases, we have to put it here. So if grid is 0, or whenever I is less than 0, or j is less than 0, or j is greater than grid, or greater than equal to grid length, or j is equal to grid I length. By doing this, we can avoid the edge cases, right? So now we're able to look at the left one, index out of bound, and it doesn't exist, so it will return 0, right? So it will return 0, and we're done with all 4 position. And then after this, what we have to do, we have to come back to here, right? But we have to come back here with returning 1, so that the result can be added by 1, right? So result is going to be added by 1, and then we look at the next one. 0 just proceeds, 0 return 0. This is 0 return 0, and here we have 1, right? So first thing, we pass this condition because this is 1. So grid ij is 0, change this to 0. Look at the upper one, look at the right. So look, we're in this code right now. Looking at the right one, and we start again from here. We have a new pointer recursively, change this to 0. So we here, and we recursively go back again. We pass this code, and then this will change this to 0. Change this to 0. Look at the upper one, right, down, left, and then come back, and it will return 0 from here, right? And it will, the recursive loop will be ended, and then we will come here. So we're at the red pointer again. We look at the down one. This is index out of bounds, so return 0. This is left, this is 0. So we're done with this, and then it will return 1, and then the rest, the result will be added by 1 again. And then the last element, 0, this is 0. So we'll proceed. And now, in that case, we are done with these 4 loops, this big for loop, and we will have to return result, which is 2 in this case. We have an error index out of bounds, grid ij's. Oh, so we have to put this at the end because the code, when the code look at the or, like look at the condition, they look at this first, right? But whenever the I is out of index bound, it didn't come, it doesn't look at this code first, so we have to put this at the end. To check the index out of bound first, and then look at grid ij. This is how we solve number by length by DFS.